Okay, 4.5. Define precession and relate the frequency of the precessing to the composition of the nuclei and the strength of the applied external magnetic field. So precessing is what happens when a spinning object undergoes precession. An object that undergoes rotational movement about an axis is said to be spinning. Example, the Earth spinning on its axis through the north and south poles. A spinning object has angular momentum, and we've brought that up several times already in 4.1 to 4.5. A spinning top will move so that its axis of a spin traces out the cone shape. This movement is called precession. Precession occurs in order to conserve angular momentum. So the number of times the axis of spin precesses per second is the frequency of precession. So a nucleus may have a net magnetism and a net spin due to its composition. This means the spinning nucleus will behave like a spinning bar magnet. If placed in a magnetic field, the nuclear magnet will precess with the external field lines, and we just talked about that in 4.5 about parallel and anti-parallel alignments of hydrogen in the body when it's exposed to the magnetic field strengths of 1.5 Tesla. So the frequency of precession, the Lamore frequency, depends upon the strength of the applied magnetic field, which we just discussed, and the geometric ratio of the frequency of precession of that particular isotope. So the Lamore frequency is the frequency at which the nucleus precesses around an external magnetic field line. So in other words, the number of revolutions the rotational axis of the spinning nucleus will complete in 1 second. So the Lamore frequency is not a constant, but is dependent on two factors: the nature of the elements and the strength of the external magnetic field. So what I'll get you to do, if you're following in medical physics in my class, I'll get you to highlight the words and the sentences in bold for me.